Welcome back from your snow day, and today we're going to talk a little bit about electrical energy and how it relates to charge and closeness and awayness from objects. So, first of all, electrical energy which we've designated before as capital E, lowercase l, is a potential energy caused by the attraction and repulsion of electrical charges. This picture right here is a picture of a Van de Graaff generator with some pi tins on top of it. When the Van de Graaff generator gets super negative, it pushes those pi tins off, and those pi tins eventually fall off to the side because that charge is so much, the charge of the Van de Graaff generator is so great. Now, a couple of things that allow us to predict the strength of electrical energy. First of all, something that I've been saying often is that opposite charges attract, like charges repel. That's something that I've said multiple times, and hopefully you will remember that already. And then we have objects with stronger charges have more electrical energy. We'll give an example of that. Closer like charges have more electrical energy, and also farther opposite charges have more electrical energy. So when closer things with like charges, they have a lot of electrical energy, and farther things with opposite charges tend to have lots of electrical energy. So take a look at a couple of examples. Here I have a Van de Graaff generator that is incredibly negative. I have two pi plates. They both have the same amount of negative charge. One is a lot closer than the other, and so the question is, which one has more electrical energy? And the answer to that question is the one that's closer. So, and the reasoning behind, if I go back to my predicting the strength of electrical energy rules, would say that objects closer like charges have more electrical energy. So closer like charges have more electrical energy. Okay. Another example would be I've got two balloons. They are both positive charged. The first balloon, this particular one balloon, has a +2 charge. This balloon has a +3 charge, and the Van de Graaff generator is incredibly negative. So the question then is, which of the balloons has more electrical energy? And the answer would be this balloon right here would have more electrical energy. Why does it have more electrical energy? Because stronger charges have more electrical energy. All right. And then we have another balloon situation where this one has a +2 charge, and this one has a +2 charge also, and this Van de Graaff generator is incredibly negative. And then the question says, which one of these balloons has more electrical energy? And so in this case, the answer is that guy. Now, that particular one is more electrical energy because it has farther opposite charges have more energy, electrical energy. Okay. And then lastly, example 4, in which case you are supposed to draw an energy bar chart for the pi plate as it moves up and away from the Van de Graaff generator. This is the pi plate at position A. This is the pi plate at position B. And the question is, at position A, it appears that the pi plate only has electrical energy. And then at position B, it has gained some height, so it's got some gravitational, and it still has electrical energy. So that is the essentially long and short of electrical energy as you need to understand it for the scope of this class. What I need you to do now is to work on worksheet number 6 for your homework, and we will go through that tomorrow. Good luck.